Today we're going to be looking at oxygen sensors. We're going to be looking at narrowband and wideband oxygen sensors. Here we're going to look at the different waveforms, different scan tool data, and output controls, and just explore all aspects of these sensors. Here we can look at the wiring diagram for the Buick oxygen sensors. We're going to specifically look at the upstream sensor. We can see at pin B we have the reference voltage sensor, or the signal that we're going to be testing. We can see at pin A the low reference of the ground, and then the heater control circuit at pin C and the heater ground at pin D. Here we can see the sensor on the vehicle, and here we can see a notice with very interesting information, including how to handle the O2 sensor and even not to solder and repair wires to the O2 sensor. Here we can see on the scan tool for the Buick Lucerne, we can see that the vehicle just started is still in open loop. And we can see our data coming in from our upstream and our downstream O2 sensors. As you can see, around 0.6 to 0.8 on the upstream and around 0.2 for the downstream. And then you can see how it's affecting our field trims, but in open loop we are still using default values as positive field trims. Now you can see that we've entered closed loop. We can view the sensor data too as it slowly switches back and forth, and we can also see how field trims are affected. Here we can see closed loop and the injector and the O2 sensors as they switch, and how it is affecting our field trim. Here I am on the heater circuit, and I can see the 9.5 volts supplied to the heater. Here we can watch the waveform of the O2 sensor, the upstream sensor. This is on the signal circuit. We can watch as the sensor switches. We can examine these waveforms to watch the sensor switch from lean to rich. Now I've created a vacuum leak in the engine. And with this vacuum leak, it struggles to run, and you can see how the oxygen sensors become very erratic. And our short trim and field trims have gone to default values. Here is an O2 heater output control with the vehicle running. You can see the vehicle running and our different PIDs. We can see we are in closed loop, and we can see our O2 sensors switching. Now we can cycle our O2 heaters on and off. Now with the O2 sensor unplugged, we're going to attempt starting the vehicle. The vehicle starts while it is still in open loop. And as you can see, it won't enter closed loop without any information coming from the O2 sensors, as you can see. Now with a misfire caused, you can see as we won't go into closed loop, and we can see a very slow response from the O2 sensor. And fuel trims, short and long term, going to 0. Here we are looking at both the upstream and downstream sensors on the Jeep. We will be looking at the sensing circuits on pins 3 and 4 of both sensors, and the heater circuits on pin 1 and 2 of both sensor circuits. Here again, we can look at the waveforms of both the upstream and downstream sensor circuits. We can view on the blue the upstream, and in the red the downstream. We can watch as the sensors switch, reading lean and rich. Now we can see what the PCM is interpreting those signals as. You can see when we went into closed loop, the upstream starts switching, and we can also see as it's interpreting rich when lean, and now our downstream sensor is monitoring our catalytic efficiency. Here we are measuring resistance across the heater circuit of the upstream sensor. Here we are looking on a personal vehicle, on a newer vehicle. We see 4 oxygen sensors, 2 upstream and 2 downstream sensors. Both are conventional zirconium sensors. Here we can see as the vehicle went into closed loop, we can look at our upstream sensors begin to switch, reading in millivolts. And we can see on our bank 1, sensor 1, the upstream sensor starting to switch. And as we can see, our about 0.9 down to maybe about 0.1 switching voltages, AC current, and our downstream sensor measuring catalytic activity. We can see the same on the bank 2 sensor, upstream and downstream. And as we give RPM, we can continue to watch this. This is a conventional sensor. Here we can also see how the heaters are commanded on, and we can see the pulse width modulation. It is commanded at 61% duty cycle. Here is a newer 2022 GMC Sierra with a 2.7 liter turbo. Here we can see this is the first vehicle truck to include a wideband sensor, as you can see, and we can also include waveforms supplied by the manufacturer to help with diagnosis of different cylinder concerns. Here we can see our control of the upstream oxygen sensor. We can see our duty cycle for our heater control. We can see different air fuel measurements. You can see lambdas there and other fuel controls. You can also manually adjust and control the duty cycle for the heater control state. Here is another view on the Colorado. As you can see, the air fuel mixture and the voltage of the heated oxygen sensor. Here on the Hyundai Tucson, we can see examples of the wideband circuit. Here we can see what different pins, as we can see this is a nurse cell sensor. We can also see the pump cell voltage and a reference voltage along with the heater circuits. This encompasses the entire wideband circuit. Here we can see a diagram of the wideband sensor, and here we can see different resistance values that are used to measure these wideband sensors. Here we can see on the Tucson, looking at different data, we see our engine speed, the actual lambda value, as we can see, as it hovers around 1, the lambda control, essentially saying it's into closed loop. Different correction values for lambda, the duty cycle for the heater circuit. You can see it's required for what it's wanting at the moment, and we'll also have a misfire counter when we give it a misfire. Now we can see that when we caused a misfire, we can see the change in the actual lambda values tending below 1 now. And we can see as our counter starts going up too. And our correction value has also changed. Now we can also see with the misfire corrected and a small vacuum leak created, we can see how it's changed our lambda values and how it's wanting to correct those values. Here we're going to inject propane into the intake manifold as we watch different sensor data, as we can watch how it affects with this rich condition.
There we are.